Our first result on GCDs will be the following theorem that I'm going to set you up for, but we're not going to prove. Again, you're going to prove on your own. So we are going to suppose that we have integers a, b, and c such that a is the sum of b and c. And we want to also assume that a and b are not both 0. And the reason is if they're both 0, the GCD of 0 and 0 doesn't make sense. There's no greatest common divisor of 0 and 0 because everything divides 0. So you can't have a greatest common divisor because if you gave me one, I would just add 1 to it and I would get a larger one. Okay, so with that hypothesis that they're not both 0, when you have this happening, if you have a common divisor of a and b, then that's also a common divisor of b and c. And the greatest common divisor of a and b is the greatest common divisor of b and c. So the proof idea is we need to show that the GCDs are the same. So what we can do is we can set D to be one of them. So D is the greatest common divisor of A and B. We want to show that D is also equal to GCD of B and C. So we want to show that D satisfies the definition of being the greatest common divisor of B and C, given that all we know about D is it's the greatest common divisor of A and B. So how do we do this? How do we show that it's the GCD? Well, it has to satisfy the definition. To satisfy the definition, D needs to divide B and D needs to divide C. And we need to show that if we have any other common divisor, that it divides D. So that's what we need to do. And you should take a minute and try it out. And then as a follow-up question, the following investigation is actually a useful investigation. So what it says is, actually, what was special about the previous theorem? So in the previous theorem, Q is equal to 1, right? So A is B plus C, so that's Q is equal to 1. And we said then that GCD of A and B should be the GCD of B and C. In this question, it's asking you, was there anything special about Q being 1? Or could you have Q be any integer? So again, take a moment and think about this, and this is something we'll investigate in class.